Welcome to this week's edition of This Week in Civil Engineering, also known as TWICE, a weekly news show focused on providing civil engineering professionals the most important and relevant industry updates. I'm your host for this episode, Danny Liu. I'm a chartered civil engineer specialising in highways and infrastructure in the UK. I also run civilengineeringmentor.com, supporting graduates in pursuing a professional qualification with the Institution of Civil Engineers. You can find all the episodes of This Week in Civil Engineering at twice.news, that's twice, TWICE.news, references to all of the news stories covered within the episode show notes. And if you're watching on YouTube, be sure to subscribe to the TWICE playlist to receive the weekly episodes. Now it's time for what's happening this week in civil engineering.
First of all, happy Thanksgiving to all our US fans. We wish you and your families a peaceful and restful holiday. Now it's time for this week's news. You're about to hear excerpts from the stories referenced. Links to all of the full articles can be found at twice.news. First, let's cover the biggest breaking news stories from this past week that might affect civil engineering companies and professionals. Firstly, drone-based assessment software aims to prevent disasters in aging infrastructure. Grant Cameron at canada.constructconnect.com. Founders of Nixon, a Victoria, British Columbia-based technology company, have developed a novel drone-based collection and damage assessment software system to inspect and detect problems with aging infrastructure. The system was recently used to inspect dams for BC Hydro and could soon play a major role in maintaining aging bridges, tunnels and other types of infrastructure across Canada, the US and around the globe. The system uses visual, acoustical and infrared heat sensing to get an idea of what it's like below the surface of a structure and detects cracks, voids or other problems in the concrete. Drones fly around large civil infrastructure projects and collect the information using an onboard acoustic recorder, optical camera and infrared camera. The data is analysed in real time using the company's software. From the information provided, inspectors can tell the width, length, depth and overall significance of the defects and if necessary take immediate action to repair them. Using a drone to collect data is much safer than traditional labour-intensive methods of assessing structures. Crews often have to hang over bridge decks suspended by ropes to analyse the surface of concrete and tap a structure. The job can be dangerous. The system can also be used to track damage over time so civil engineers can plan in preventative maintenance. It's great to see the continued development of drones and how they continue to make it easier and safer for civil engineering professionals to do their jobs. Next up, let's look at an interesting story from the US. Machine learning takes a crack at facade inspection, from Jeff Rubenstone at ENR.com. Getting machine learning and artificial intelligence to work for construction is often a matter of finding where it would be most useful. AI algorithms can scan through terabytes of data looking for small inconsistencies or hidden patterns that a human might not notice at first. Now, engineers at Thornton, Tomasetti have applied that considerable processing power to the tricky work of building facade inspections. After 2 years of development in Thornton Tomasetti's core lab, the result is T2D2, the Thornton Tomasetti Damage Detector, computer vision machine learning algorithm that can identify damage to building exteriors in photos or video. Not intended to replace the difficult work of facade inspections, the T2D2 is instead seen as a tool to find hidden damage that might go unnoticed and speed along a tedious, difficult process. On a typical image, T2D2 goes through several steps. Using its knowledge base of thousands of previously annotated images, it quickly identifies the geometry of the structure and assigns material types. T2D2 then does a pass to identify potential damage that would be found on each type of material. It then outputs a marked up version of the image with potential facade damage highlighted and classified for review. While T2D2 was initially trained primarily on concrete structures, it can now be found and classify damage on brick, masonry, stucco and other commonly used facade materials. To learn more about T2D2, visit structuralengineeringchannel.com, where you can find a detailed interview with Dr. Baudry Hirier, PhD, Vice President and Director of Artificial Intelligence at Thornton Tomasetti on episode number 36 on NORWAY'S podcast, the Structural Engineering Channel. Next up, US news in civil engineering. First, let's head to Virginia. Tallest bridge in Virginia now open to traffic. From Slater Teague at WJHL.com. Virginia Department of Transportation announced that the twin bridges over Grassy Creek opened on Monday. The bridges located near Brakes Interstate Park are about 265 feet tall and 1,733 feet long. They are part of Virginia's DOT's Route 460 connector project, which will run from Grundy to the Kentucky state line. Construction began in 2015. Kentucky has also opened a portion of Route 460 on its side of the state line, so the stretch of highway now links Brakes, Virginia to Beaver, Kentucky. Next up, let's head to Kansas. Ground breaks on construction for new railroad. From Ashley Soriano at KGNS.TV. Contractors for the Kansas City Southern Railway Company began drilling in soil near the International Bridge. KGNS called video footage of the crews Thursday as they're in initial engineering stages to add a parallel bridge to the existing International Bridge in Laredo. The project will make the existing train traffic safer, more secure, more fluid, reduce traffic congestion in downtown Laredo, and allow for growth in the future. This is just one project underway in Laredo. It is possible of a second, which would include elevating the railroad through downtown Laredo to reduce traffic congestion. The elevated railway would be 9 miles long and allow for trains to travel north and southbound. The cost of the second project is undetermined. Projects focused on reducing traffic congestion should become more and more common with population growth. We monitor these projects and attempt to interview professionals who work on them to share lessons learned. Next up, some career inspiration for you.
Let's take a quick break from the news for this week's Civil Engineering Career Inspiration. So which project inspired me to take on a career in civil engineering? It was actually the Channel Tunnel, which is a 50-kilometre railway tunnel that links the UK and France. It was actually first designed in 1802 and first excavation attempts was made in 1880 but then abandoned. Full construction started in 1987 and then finished in 1994. The tunnel boring machines were laser guided, and when the two tunnels were 100 metres away from each other, the lateral offset was only 380 millimetres. That's just amazing. Now let's get back to the news.
Next, let's move on to some international news in civil engineering from this past week. First up, we headed to India. India awards first contract on $3.3 billion high-speed rail. From Saibal Dasgupta at ENR.com. Mumbai-based Larsen & Toubro emerged as lowest bidder for a 508-kilometre, $3.3 billion bullet train project, a signal that India will build its first high-speed rail project using local capability and was awarded a 237-kilometre sector. The Mumbai to Ahmedabad project attracted 4 bidders, all Indian companies. Others were Afcon's Infrastructure, International Indian Railway Construction Company Limited, and a consortium of National Certified Councillors, Tata Project, J. Kumar Infra Projects, and High Speed Rail. Larsen & Toubro's portion of the project between Vapi and Vandodara includes 4 elevated stations, 1 train depot, and an 88-kilometre long viaduct. Japanese companies are expected to provide locomotives and coaches for the high-speed trains along the Mumbai to Ahmedabad route, although the Indian government still has the option to pursue international bidding to get the best price offer. The Mumbai-Ahmedabad high-speed route is expected to reduce the travel time between the two cities to less than 2 hours compared to the current time of more than 7 hours. There will be a dozen stations and 2 rail depots. Wow, what an exciting project! A reduction of 5 hours in travel time. This is a real example of how transformative engineering can be. A project like this can do so many things for people both culturally and economically. Next up, let's head to Barcelona, Spain. How robots could save one of the world's most unusual cathedrals. From Mark Foster Gage at edition.cnn. The Basilica de la Sagrada Familia is by a rather large margin among the world's most complicated and time-consuming architectural projects ever undertaken, still under construction over the heads of 4 million annual visitors. While technically a basilica, as it does not have a sitting bishop, somehow even the word cathedral seems too minuscule to fully describe the overwhelming scale and complexity of both this massive building and geological timescales of its construction. It's one of the most ambitious, visionary, unusual and long-lived architectural projects in the history of humanity, currently clocking in at 138 years of construction, which for comparison is over 6 times as long as it took to build the Great Pyramid of Giza in Egypt, and it's still not finished. While little progress has been made over essential construction, since 2000 the assistance of computers and robotic tools has supercharged the construction process. By 2009, this incredible growth spurt allowing the vaulting over the central nave and apse to be completed. The Sagrada Familia finally had an interior. By 2010, there was still much to do, including building 10 remaining towers, 2 sacristies, some ancillary internal structures, and the cloister enclosing the whole building. By having an actual interior, however, the basilica can now officially be used for Catholic Mass. In the past 2 decades, the construction team has added even more digital tools to their repertoire, including 3D printers to produce scale models that allow them to better study the designs and test how to construct them, and LiDAR laser scanning techniques, which allow builders and architects to digitally scan the parts of the building that have already been built, to both check for accuracy and produce precise digital models that they in turn use to design new components of the building. Wow, talk about long construction duration. If you have ever seen this cathedral, you'll probably agree it's worth it. Next up, let's head to Norway. Norway's new green highway route from Nopassin Wingchom at worldhighways.com. A new highway stretch in Norway will help cut journey times between the capital city Oslo in the south of the country and the nation's 3rd largest city Trondheim in the north. Driving the 495km route has typically taken around 6 to 7 hours, but a new 27km highway stretch will reduce journey times. Named the Green Shortcut, this new highway stretch offers an alternative route that reduces the distance between the 2 cities by around 40km compared to the existing E6. Using this stretch reduces journey time by around 45 minutes to some 6 hours, allowing fuel savings for drivers also. The Riksvei 325 is one of Norway's most important national roads, as it connects the south of the country with the north. Improving the road has proven a significant task for the Norwegian Public Roads Administration, as the route passes through scenic natural landscapes and as a result poses environmental challenges for the builders. Although this new stretch is just 27km long, it features 28 separate civil engineering structures and has been built with 2 lanes in either direction. The project also features 7km of cycle lanes and facilities for pedestrians, a new traffic station for road administration, and a number of wildlife crossings. Reducing travel times and traffic congestion certainly seems to be a theme for this. On that note, let's finish up with a few infrastructure related stories, starting with some general news about infrastructure projects. Seismic rebuild plan for Museum of Anthropology. Staff reporter at RIMINetwork.com. The Museum of Anthropology at University of British Columbia has begun preparations for a rebuild of its iconic Great Hall that will upgrade the resiliency of the space and protect its collection in the event of a major earthquake. The most recent round of University of British Columbia building valuations, undertaken as part of a campus-wide seismic resilience plan, has identified the Great Hall as one of the spaces at greatest seismic risk. Based on simulations for major earthquake scenarios, it was quickly elevated on the university's priority list for seismic upgrading. As the undertaking calls for a sensitive approach given the heritage value of both the building and its site, the university met with Arthur Erickson Foundation, which advocates for proper stewardship of Erickson's legacy. Representatives from the Musqueam Indian Band also participate in planning meetings and provide a cultural perspective for the project team to take into account. The seismic upgrades will be achieved using base isolation technology. In this type of construction, the Great Hall will be placed over rubber or sliding bearings known as base isolators. in between the foundations and superstructure. As the ground shakes, the isolators will allow the building to move, taking up most of the energy and protecting the building structure. Seismic upgrading. It's great to see organisations being proactive in this arena. EMI is seeking to interview one of the NORWAY'S representatives on an upcoming episode of the Structural Engineering Channel podcast. This can be found at structuralengineeringchannel.com. Next up, to the windy city of Chicago. Aldermen OK's plan to borrow $1.4 billion greenlight 5-year infrastructure plan. From Heather Sharon at news.wttw.com. A plan to borrow $1.4 billion to repair Chicago's crumbling streets, sidewalks, bridges and shoreline during the next 5 years advanced on Wednesday with a 22-10 vote of the City Council's Finance Committee. Hours before the vote, Mayor Lori Lightfoot released a 24-page plan that calls for the city to spend $3.7 billion to remake the city's aging infrastructure and put thousands of Chicagoans back to work while addressing a decades-long backlog. The borrowing to fund the capital plan, which Lightfoot vowed would address the area's highest need whilst combating climate change with sustainable projects, advanced as part of the 2021 budget package, which relies on a separate plan to borrow an additional $1.7 billion to refinance existing city debt to save $450 million in 2020 and $501 million in 2021. The city will have to start paying off the debt that will fund the capital improvement program in 2022, $25.5 million in property tax revenues. Investment infrastructure seems to be at an all-time high, which should keep civil engineering professionals busy for a long time.
To wrap up, here's an inspiring quote to motivate you for the rest of your day. Booker T. Washington said that if you want to lift yourself up, lift up someone else. Due to COVID-19, we're all living and working in strange times and many of us are struggling with feelings of depression. So why don't you take some time out today to call, email or WhatsApp a friend or colleague and just ask how they're doing. I'm sure they'll appreciate it. There you have it. That's what's happening this week in civil engineering. You can find references to all the stories mentioned at twice.news. And all episodes are also published in video on EMI's YouTube channel at youtube.com/engineeringcareers. Remember to subscribe on Apple Podcasts, Spotify, or wherever you listen to podcasts, and of course YouTube for the video version. This is Danny Lou signing off. We'll see you next week. Now go and be the best civil engineering professional that you can be.